3/4 cups of flour to, milk powder to make 6 dog biscuits. So whatever they said first is going to go, excuse me, as the numerator. And whatever they say second is going to go as the denominator. So now you divide by the denominator to find the unit rate. So you're going to divide this by 6/1, and you're going to divide this by 6/1. So now for the numerator, we're going to rewrite the first fraction, change the division to a multiplication, and flip the second fraction. And then we simplify, and it becomes 3/24, which then can be simplified to 1/8. Does that make sense to you?
Yeah.
Okay. And then 6 times 1/6 equals 6/6. So the numerator is 1/8 and the denominator is 1. The denominator is always going to be 1 because you're trying to find the unit rate, which means if this is what we're doing for 6 dog biscuits, we always are trying to find what 1 will be. So you would have to use 1/8 cup of milk powder for 1 dog biscuit. Make sense?
Yeah.
Okay. So sometimes they're going to have mixed numbers. So if we had a mixed number, it would be 18 2/5. You would first change it to an improper fraction. So 18 times 5 is 90 plus 2 is 92/5. Does that make sense to you?
Yeah, so you did 18 times 5 plus 2.
Yeah. And so that's your numerator, and the denominator was 4/5. So we're just going to rewrite that down here. And now we divide by the denominator. And then we keep change flip for the numerator. And we keep change flip for the denominator. So this becomes 20/20, which equals 1. That's our denominator. And our numerator is 92/4. Oh, I can go lower here. Sorry. We should just simplify, make our life easy. So this can be divided by 4, and it becomes 23/1. Does that make sense to you?
Yeah.
Do you know how to cross cancel?
Yes.
Okay. Awesome. So if we were traveling 18 2/5 mile, and that uses 4/5 gallon of a tank of gas, then this tells us that $23 miles for 1, not tank of gas, 1 gallon. Make sense?
Yeah.
All right. The next section is page 26, and they're saying you're going to use ratios to solve real world problems. So to find the length of a board in terms of feet, it is 1/4. Let me show you the problem. Here we go. So what is the ratio of the length of the tile to the length of the board? What is the ratio of the area of the tile to the area of the board? How many tiles will fit on the board without overlapping? So this is 1/4 of a yard, and this is 1/6 of a yard. And so they're going to say, let's find the length of the board in terms of feet. So 1/4 of a yard times there's 3 feet in 1 yard. Does that make sense to you?
Yeah.
So our ratio is going to be 3 feet to 1 yard, and then you multiply across, it becomes 3/4. Now, to get rid of the fraction here and make it into 1, you're going to multiply this times 4 and multiply this times 4, and then you're going to get 1/3. So the ratio of the length of the tile to the length of the board is 1/3. Next one is the ratio of the length of the tile to the length, 1/6 feet times 1/4 feet would be the area because it's length times width. Does that make sense to you?
Yeah.
Okay, so area equals length times width. We plug in the length, which is 1. Why are they saying 1/6 is the length? 1/6 is the width. I don't know why they reversed that. Weird. Okay, so it becomes 1/24. It doesn't matter. It would still come out to be, so they did 1/6 times 1/4. I'm going to do length times width. I don't know why they switched that. It still comes out to 1/24 feet squared. So anytime you have area, your units are in feet squared or yards squared or inches squared. Okay, now we're going to say it again, honey.
So when you say you have a word problem, do you just say squared at the end?
You just do an exponent of 2. Can you see that? That's how you always show area, in units and then with the squared exponent right here.
Okay.
Make sense?
Not really.
Okay, so anytime, like if we have just plain old length and width, suppose it was not a fraction, and you had 8 for the length and 4 for the width. To find the area of anything, you do length times width. So we're going to do length is 8 and width is 4. Then you do the math, and it's 32. Suppose this was in inches. You're always going to do your label, whatever it is, inches, feet, yard, meters, and it's squared because area is always in units squared. If they wanted us to find the perimeter is 2 length plus 2 width. So we would plug in our length here, 2 times 8 plus 2 times 4. And then we would solve. 2 times 8 is 16 plus 2 times 4 is 8. Perimeter equals 24. Say this was inches again. And it's just plain old inches. Area is always inches squared. And then volume, if you were to do volume is always in, if it was inches cubed. That is just a fact. It doesn't have to make sense. What it means is perimeter is always just in inches. Area is always in inches squared. And volume is always in inches cubed. So you're never going to do a problem of area and not put label squared, ever. Anytime you figure out area, you're always going to do it in yards or feet or meters squared, and you always write the answer exactly like this. Meters squared, inches squared, feet squared. It's just how we express the answer for area. Perimeter is always in just the label without anything. And volume would be meters cubed, inches cubed, feet cubed, whatever it is, all the time, 100% of the time. There's never an exception to that.
It's wrong if you don't do that, right?
Yeah, I would mark it wrong because it's wrong. Yep. So basically what it means is San Francisco is 7 miles. I guess it would be a square. Forget about this. It's 7 miles by 7 miles. That's how big San Francisco is. It's 49 square miles, which means this way and this way. It's not just 49 miles. It's 49 miles. So if you were to divide up San Francisco into 1 mile units, there would be, I don't know if this is 49. 1, 2, 3, 4, 5, 6, 7. I got close. 1, 2, 3, 4, 5, 6, 7. This would have 49 blocks of 1 mile. That's what that means. Does that make a little more sense to you? Which is why it's not just miles, it's miles squared. It means each little block of unit, there'd be 7 of them, and each block would be 1 mile this way by 1 mile this way.
Yeah.
Okay, can we go on from there? Okay. All right. Same kind of problem here. So they are doing cups of rice to broth. So you need 3/4 cups of rice to 3 3/4 cups of broth. So you would put your ratio out, 3/4 as your numerator and 3 3/4 as your denominator. Now we want to make this easy to work with, so we have to change our mixed number to an improper fraction, and that would be 15/4, which is why they put that here. Does that make sense to you?
Yeah.
Okay. So the next thing we would do is to divide each term by the denominator. Yeah.
I actually already said yeah, but I didn't know.
Okay. So it's hard to work with a mixed number, so we have to change it to an improper fraction. So let me make this clearer. Okay. So
all they did was just change it to a improper fraction.
Yes.
I mean proper fraction.
No, this is an improper fraction. That means that the numerator is bigger than the denominator. And the reason why we do that is this is too hard to work with. You never want mixed numbers in your problem. You're almost always going to change them to an improper fraction unless you're adding them. Then when you're adding them, it's super easy because you would just do 3 3/4 plus 1 1/2. It actually is very easy to keep it. Three plus 1 is 4. So it's 4 5/4. And then you would change this into 1 1/4 and add these together. So that's pretty much the only time we would keep a mixed number. All the rest of the times you would always change them if you're doing algebra, if you're doing measuring, if you're doing anything else, multiplying, dividing, you're always going to change your mixed number to an improper fraction. It's just way easier to work with. So you're going to divide each by the denominator, which is now 15/4 because we changed it into an improper fraction. And so when you do that, we're going to get you said you do know how to cross cancel, right?
Yeah.
Okay, so we're going to do 3/4 times 4/5, and then we're going to cross cancel, and it becomes 3.
When you cross cancel, do you just do 1/4 over 5/1, and then they just cancel each other out? So.
You mean these cancel each other out?
Yeah.
Yeah.
And then you just do 3/5.
Yep. And then this is going to be 1, right? Because 15/4 times 4/15. And that is it. All right. Make sense?
Yeah.
They show a lot. I'm like, what the heck are they doing? All of this, but it's what we just did. So that is pretty much what you're doing for the rest of the chapter. Then you're going to be doing proportions. Did you do proportions yet? No.
Yeah, we did it the other day.
Okay, so maybe you're kind of going on to chapter 2. So the proportions are when they tell you something like there are 2 circles, and for every 2 circles there's 1. The ratio is 2:1, and you could show it as 2:1, 2:1, or a fraction 2:1. The main thing to remember is we always keep ratios and proportions. Whatever they said first goes at the numerator or goes first in the list. Whatever they say last always goes as the denominator or it goes last in our list.
I did these with you 2 weeks ago.
Yeah, I knew. I go, this looks so familiar. Okay, good. So we already know we did these ones, right? This makes sense to you?
Yeah.
All right, good. So that's pretty much what you are doing for most of 2.1. 2.2, we're doing the same exact thing. They're just doing it as a graph. So basically what they're saying is this is our x-axis. Do you remember that from last year or no?
Yeah.
Okay. So the x-axis means that you have a bottom part. Let me get a piece of paper. So you have a bottom part of a graph, which is this part. It's the horizontal line. This is your x-axis, and this is your y-axis. And these numbers right here are negative numbers. These numbers over here are negative numbers. These numbers up here are positive numbers. And these numbers right here are positive numbers. So this is called quadrant 1. This is where our positive numbers are. Here is quadrant 2. The y is positive and the x is negative. Does that make sense to you? Here's the negative x-axis and here's the positive. This is negative and negative. Does that make sense to you? If you're going to put a point here, it's going to be a negative number and a negative number. Does that make sense to you?
Yeah.
Okay. And then this is axis 4. It's going to be a positive x and a negative y. So when we are graphing anything, they're going to give you 2 points to graph. The first one is going to be the x, and the second one is going to be the y. So, what, honey?
I feel like I did this exact same thing last year.
Yeah, you did. This is a review. So they're going to tell you what x is. So in this case, they're going to tell you that time is x. So for time, they're going to tell you that you're going to go to 4. And there's no negative numbers here because there's no such thing as negative time and there's no such thing as negative heartbeats. A human being cannot have negative heartbeats. It has to be a positive number. So what they did was they just got rid of all the negative numbers because we do not need it. In the case of what they're using, you cannot have negatives. There's no such thing as negative seconds and there's no such thing as negative heartbeats. So you're only seeing this part of the table. Does that make sense to you? They got rid of the negative.
Yeah.
So we're left with this. And the X is 4. And the Y is 6. So we're going to go over 4. And we're going to go up 6. And we're going to put a dot. This is called a point. Then we're going to go to 6 and 9. And we're going to put a point. Then we're going to go to 10 and 15. And then we're going to go to 12 and 18. So you're going to have these 4 points right here, and you're going to draw a line through it.
Yeah.
Okay, so does that make sense to you?
Yeah.
Okay, so if we had a table that looked like this, we would do, there are no negative numbers. So I'm just going to make life easy and put it right next to the table. So we're going to graph 0 and 0, 1 and 6, 2 and 12, 3 and 18, 4, obviously I'm just guessing because we don't have all the numbers plotted, but it's going to turn into, pretend like my line is straight.
Okay.
So that's what it would turn into. That's what you're going to do. You're going to plot all of the data points. So that is how you do it. Okay.